This is the fast forward of Czech 2018. Enjoy.
Good day, I'm Mark Zabran from the University of West Bohemia, and I've created an algorithm which recreates triangular mesh from its edges. This algorithm is simple, purely topological, seems to run in linear time, and most importantly, also solves the inner phase removal problem. So if you are interested, see you tomorrow.
My name is David Paleń. I'm from West Pomerania University of Technology in Szczecin from Poland. We built multi-material 3D printer which has two separated nozzles, so we can use PLA filament to print actual 3D object and PVA filament to print support that can be rinsed with water. If you want to know how to build 3D printers, please come to my talk.
Hi everyone, my partner is Viktória Burkus, my name is Attila Kárpáti. We came from Budapest. We will present tomorrow an algorithm which can generate three-dimensional trees from interlocking pieces. We adopted texturing and tessellation algorithms too. We made the foliage depending on 2.5 dimensional impostors. So come tomorrow.
Hello, my name is Florian, and tomorrow I will show you how we render a procedural planet. We focus on terrain and ocean mesh generation. We extend the planar wave function to the spherical domain, and we perform unified atmosphere and clouds reimaging. Our solution runs in real time and does not suffer from any distortions or seams. Due to our unified rendering approach, we can achieve a seamless transition from ground to space. If you're interested in how we do this, then visit my talk tomorrow. Thank you.
Hi, I'm Patrik from Slovak University of Technology in Bratislava, and I work on eye tracking. Knowing where a user is looking on a screen is very useful for example, usability studies or user experience studies, which are unfortunately limited by the need for eye tracker devices. However, every mobile device today has a front-facing camera or web camera which could be used for eye tracking, and this is what we do through neural networks. We record the appearance of the user and then build on existing models and try to improve already accuracy of existing models. Thank you.
Hi, I'm Thomas Koch from TU Wien, and this is a visualization of HRV produced by Marion. Marion is a system to visualize biological data, and I've used screen space techniques to improve the figure ground perception of a scene by incorporating the semantics of the molecules into the occlusion calculation. And if you want to know more, then come to the poster session tomorrow. Thank you.
Hi, I'm Attila Szabo. For my diploma thesis, I implemented a photogrammetry pipeline, and photogrammetry is complicated. And luckily, we have a tool to deal with complicated things. It's called functional programming. If you're interested in functional programming or photogrammetry, and you should be, then check us out at the poster session tomorrow. Thanks.
Hi, my name is Andreas Weich, and I'm from Vienna. I will present my diploma thesis. I'm quite sure everybody of you have already taken a camera and tried to create maybe one of those beautiful, colorful images, but also sometimes they are not so really wanted, like here in the football game. We try to render those, and while creating a physical, simulating the physical appearance of those lens flares, we try to predict it to avoid certain constellations or to generate certain constellation to create it. Thank you.
Hello, my name is Dundr, and my talk will be about variance-guided filtering of path tracing. So here we can see just simply path trace image. It takes about 37 milliseconds per frame, but it's really noisy. Now guess how long it takes to render this one. There's really not much noise, and it's all much nicer. It takes 43 milliseconds. It's only 6 milliseconds more. So how did I do that? If you want to know how can I do that, you can go to my talk on Thursday afternoon. Thank you.
Hi everyone, my name is Michal. I'm from Brno University of Technology, and I'm going to be talking about experimental implementation of bidirectional path tracing. I will show you how important are subset methods, path tracing and light tracing, in order to establish bidirectional estimator. And finally, I am going to focus on multiple importance sampling, which is a powerful weapon in reducing the noise from final image. So if you are interested, come to visit my talk and first day rendering session. Thank you.
Hi, so my name is Nikola, and I'll be talking to you about the probabilistic connections algorithm. So the best way to simulate realistic images like this one is to actually simulate light the way nature does it. However, once you start doing that, you run into the problem that you need to simulate infinitely many rays of light, and at some point you need to make a decision: which light rays do I simulate, which ones do I say are important? And if you're interested in how we make those decisions and how we go from the image above to the image below in the same amount of time, please come to my talk. It's going to be tomorrow during the rendering session. My name is Nikola. Thank you.
Hello everyone, my name is Tomáš Izer, and I present a novel real-time rendering approach for participating media such as fog. As you can see, these are all real-time recordings from our solution, and the objects and light sources are nicely blurred in the fog, as unlike the existing approaches, we also support multiple scattering and inhomogeneous media. It is a screen space solution. It's post-processing, which means that on the input we get a frame that was rendered the usual way, and then we process it while taking the participating medium into account. Please come see my presentation tomorrow to get more details. Thank you.
Hello, my name is Miroslav and I work on the visual attention modeling. So look at the image. We know pretty accurately where you are looking, but will this fit the real world? We assume that not really. So we introduced a novel approach to study human visual attention. We created a novel dataset to study visual attention from the egocentric perspective of view, and to define a function of depth influence on the object's visual attractivity for you. If you are interested in the results, please come tomorrow afternoon to my presentation.
Hi, I'm Laura Luidold, and this work was developed as a part of an application to help visually impaired people perceive images. I will be presenting a novel approach to calibrate a 4-component setup consisting of a movable object beneath a static arrangement of a color camera, a depth camera, and a projector, using only a single calibration target and 2 different calibration patterns, one printed and one projected. Finally, the pose of the object is detected and used to project labels onto it. Furthermore, this application will be displayed at the expo, so visit us there and come to my talk.
Hello, my name is Thomas Köppel and this is my colleague Nicolas Grossmann. We are from the TU Wien and we are doing a combined presentation tomorrow. During our work we have been using two different depth sensors, namely the Kinect V2, which most of you may know from the Xbox Kinect games, and also the Fab 2 Pro, which is a phablet that includes a depth sensor. And as you can see on this image, that the measurements are quite noisy and have quite a high amount of error. And we now somehow want to measure this error, and we wanted to quantify the error of this.
And we did this by conducting two experiments and deriving two separate models from them, and also a combined model which works even better than their parts and is able to describe this noise precisely. And if you're interested in finding out how we did that and what did we do, then come to our talk tomorrow. Thank you.
So hello, I'm Ivona from University of Sarajevo, and here on slides you will see a little sneak peek into our application that we made. So here is one video, a teaser video for our application that's about the bridges of Sarajevo. And if you're interested in history and cultural heritage and you want to know stories about the most interesting bridges in Sarajevo, then you should visit our talk in Friday. Thank you.
Hello, my name is Silvana and I represent you 3D annotations to improve the orientation and to identify flooded areas, for instance. Here you can see if we add the annotations, we can identify the flooded street. It's Postgasse in Jembach. And if you want to know how I integrated the 3D annotations into a highly interactive system, come to my talk on Friday.
Hello, my name is Ondřej Texler, and to stylize the image you really don't need this super duper fancy GTX graphics card. Graphics cards are not for graphics anymore, they are for mining bitcoins, right? So, well, actually, you can enjoy the stylization in, let's say, everyday life. For example, when you are browsing your navigation map on your mobile phone. So, again, my name is Ondřej Texler, and if you are interested, come and see me at the Friday. Thank you.
So hello, I'm Lukas Eibensteiner, and I'll not be talking about vision or graphics, but I'll be talking about music, and in particular about music generated with formal grammars. And the approach actually comes from procedural graphics, and it allows us to define a single set of rules and generate many different variations of a piece. So if you want to know how to write a program that can generate original music, join me on Friday for the last talk of this conference. Thank you very much.
Okay, hey, thanks. This was the students fast forward for the CESCG 2018. Thank you very much for the students. You did a great job, and I'm looking forward to all of the presentations. And those of you who are staying for a whole 3 days, be sure not to miss any of them, because I think all of them will be great.